Hello and welcome. My name is Alex. I'm the founder and director of MPSI Technologies. I'm happy you made it here to this virtual presentation booth, where I will talk about how we help customers to cut corners in the lab to market with automated embedded software development, among other things. Quick introduction. We are MPSI Technologies, founded 5 years ago in Munich with the clear goal to get embedded software projects done faster and with better code quality. So this is obviously a photonics event, and the reason I can speak here is not only because at some point of time I have done something with photonics. It's really because embedded hardware and software can be a crucial ingredient to success of a product in the photonics market, and we have a solution to give you these high-quality embedded solutions. I will illustrate this with the project which triggered the technology we have developed and also the services we offer, which was a European Union project where we, as an applied physics research group, committed to delivering a system which would allow, in a robotics context, to use mid-infrared quantum cascade detector arrays for search and rescue purpose. So I start from the wafer level here on the top right. So this is what is the core competency of our lab. But as I go over the various integration steps, you see that in order to fulfill our promise to deliver something useful, not only thermal packaging, optical packaging was required, but also custom embedded hardware design here with FPGA. Some more embedded hardware design to combine our then packaged detector with other sensors, a stereo camera and a thermal imager. And finally, a really big ingredient to the success was also the embedded software to make everything play together. So at that time, I already thought, well, it would be good if it would be possible to cut some corners here in the development. At that time, it was wishful thinking, so everything had to be done thoroughly, linearly, from wafer level to the finalized product. But it left me with the idea that something should be done about this. To go further, I would like to highlight or delve deeper into the aspect of embedded software. Embedded software serves to make embedded systems do their job. It can be as simple as the system shown above, which is just a microcontroller with a trivial serial interface programmed in assembly and C. But these days, embedded system can also mean these single board computers, which you see on the lower corner. I'm sure you've all heard of Raspberry Pi. But the key message is an embedded system these days can be as complex and sophisticated and powerful as a multi-core desktop computer. And it is programmed in a very different way than a traditional embedded system. Now, on one hand, this offers a lot of opportunity, obviously, to have all these nice features in these embedded systems. But also, if you now put yourself in the position of a software developer, this might also come through as a burden, because to all of these aspects that are implied in such a system, they have their own software development methods, languages, and so on. And I would like to show them how we regroup them into 3 levels. On the lowest level, there is what would have been the classical embedded system programming. It's C programming for microcontrollers, VHDL, Verilog programming for programmable logic. But the main main level in the single board computers is embedded Linux level, where you can write multi-threaded executables in C++, and you attach things like databases. You make sure that the multi-threading, the algorithms work in multi-threaded fashion, can get really complicated. And what is also important in today's connected world is that you have numerous options to connect to the outside world. So you might want to have a small web server or servers for industrial automation protocols. Finally, our third level is always external, or the outside world, and it is relevant for how your customers want to interact with your embedded system. It can be embedded web-based user interfaces, but it can also be industrial automation protocols. So to summarize, lots of technologies to be learned. If you do it the old-fashioned way, and we thought that as lots of repetitive and manual coding is oftentimes involved, it would be a good idea to have a little helper tool, and that is the core technology of our company. It's called Wisnium, and it is an open source software development tool which allows you to replace manual coding in large parts for all of these aspects mentioned on the last slide by model-based software development and source code generation. The tool is open source. It has numerous other advantages, like the generated code is also royalty-free. You can freely mix manual code with auto-generated code. But most of all, it gives you a helping hand to master all the technologies that are expected from you as an embedded software developer for such complex systems. What we also have, which is quite useful for a young startup, we have a number of happy customers owing to our tool. The one I can mention here is a solar panel tester device, which we developed for the company Sonnenglas. Sonnenglas, at least here in Germany, has a very famous gadget, solar jar, which in its lid combines a sandwich of a solar panel, a battery, and LEDs, where during the day it would accumulate energy in the battery, and at night you have a nice light. So this solar panel tester serves multiple purposes for the company. On one hand, it is for R&D. We can have really sophisticated analysis of new panels from new suppliers, but it is also implemented, it is in the production lines to accumulate data from each panel that is ever incorporated into any device, and that in turns, because of the powerful software that is involved, allows to accumulate statistics and give feedback to the solar panel supplier. We are also very eager to not only use our own tool to help make customer projects succeed, because we have limited resources. We also want other people to learn Wisnium and have the benefits of cost and time savings for themselves. So for this, we have a starter kit available with a pre-programmed solution that shows mostly all aspects of Wisnium in one nice project. It's a tabletop 3D laser scanner, which you see here. It's a turntable with a 5 megapixel camera and 2 alignment lasers, and then 4 options of single board computers with FPGA, without FPGA attached. And I would say, as compared to my situation as a project manager 5 years ago, now we have something to cut corners indeed. We are ready to serve. We are ready to help you save time as well with our tool, with our services. And this brings me to my last slide. How and why to engage with us? Well, first of all, I mean, we, especially if you come out of the lab, you have your knowledge about your maybe fancy brand new laser sensor, whatever technology. We have the experience to make a product out of it, and this involves embedded hardware and software development. We are happy to help with that. We will always use our Wisnium tool to make the embedded software work. And that implies for you and your customers that your product will be easy to integrate with all the connectivity features. And this gives you a competitive advantage over people who do everything manually. And we are also eager, or we are also very happy to help your in-house software development team to work further with the code that maybe we initially developed for you. Last but not least, we relentlessly push to get people to use Wisnium in the embedded community, because we simply think that manual coding, where it is repetitive and boring, should be replaced by model-based source code generation. So there are frequent updates on the tool, tutorial series, and so on. And I would say that concludes my presentation.